Hello Year 11, this is a video walkthrough for exam paper set 2, paper 3F. This is the third of the foundation papers. It is a calculator paper, so you will need a calculator. As normal, if you want to skip ahead, feel free to do so. We'll have split the video into sections, so you know, if you want to go ahead to question 13 because you found that one difficult, then just skip through the video as you wish. Okay. Question 1. Write down the value of 5 in 7.052. So there are two potential answers for this. You can either write it in words. So these are called units. These are called tenths. Tenths with a TH, that is. Tenths, not tens. These ones here are called hundredths, again with a TH, hundredths. And this one here are thousandths. Okay, thousandths, again with a TH. So yeah, the answer to this one is 5 hundredths or 0.05. So I'm going to write 5 hundredths. But again, you can write 0.05. I'm really concerned now that I spelled hundredths wrong, but yeah, I don't know if there's a D in there, but yeah, either way, that or that is fine. Next, simplify 4y minus y plus 2y. So treat them as things. I don't know if I've got four, think of a word beginning with y, yachts, yo-yos, 4 yo-yos, take away 1 yo-yo, that's 3 yo-yos, plus another 2 yo-yos is 5 yo-yos. Next. Right, 678,980, correct to the nearest 10,000. So I'm rounding to, well, this is thousands. This one here is 10,000s. So what I'm looking at is the 8. The 8 is bigger than 5, which rounds this up to 68, or 680 rather, thousand. Okay, so answer 680,000. Find all the factors of 40. Now factors come in pairs. They multiply to make a number. So for example, 1 and 40, 2 and 20. 3 doesn't go into it, 4 and 10, 5 and 8, and that's it. So there are all the factors. I'm going to write them in order: 1, 2, 4, 5, 8, 10, 20, 40. That's all the factors of 40. Question 5. Lynn is planning a Christmas party for her badminton club. These are the costs. Lynn wants to hire the room for 4 hours, so that's important because this is a per hour rate. There's going to be 28 people at the party, £15 each she's charging. Will she get enough money to cover the costs? Really a good real life question, comes up all the time. Maybe not necessarily when you're organising parties, because hopefully you're not trying to make money out of your parties if you're hosting people, but if you are an event organiser and you charge charge a fee for tickets, then do the income of your tickets cover the costs of the event, is the question. So let's work out the total cost first. What we're doing is 176 plus 103 plus 36 times 4. Those are the total costs of the party. So I'm going to just put that in a calculator. 176 plus 103 plus 36 times 4. You can put that in brackets so it doesn't make a difference, because BidMaths will multiply those together anyway first. Gives me a total cost of 423 quid. And then she's charging 28 people £15 each. So 28 people, £15 each. 28 times 15 gives me a total of £420. So does her income, these are the tickets, these are the costs, so does that cover that? And the answer is no, she is £3 short. So what that means is her costs are £3 more than her income. Question 6. Sabrina throws a fair coin. On the probability scale, mark with a cross the probability the coin will land on tails. If it's a fair coin, then it's got a half-half chance, so half. Suresh throws an ordinary 6-sided dice. On the probability scale, mark with a cross the probability he'll throw a 7. Now on an ordinary 6-sided dice, there isn't a 7. For those of you who play any kind of board game, you'll hopefully be aware of this. For any proper nerds like me, who I don't know, play Dungeons and Dragons and do some cool stuff like that, there are some other dice that exist. You know, you can get 10-sided dice, 20-sided dice, all sorts of different kinds of dice, but a normal 6-sided dice goes up to 6. So can you get a 7? No. So therefore the probability is 0. C. There are 3 yellow sweets and 1 blue sweet in a bag. Graham takes a random sweet from the bag. On the probability scale, marked with a cross, the chance he'll take a blue sweet. Well, if there is only 1 blue and there are 3 yellow, then he has a 1 out of 4 chance. I hope you can all see that. Yeah? Blue out of the total is 1 out of 4. Now, a quarter on this scale is halfway between 0 and a half. So, just there. That's a quarter. Question 7. Mr. Wither sells umbrellas. The scatter graph shows some information about the number of umbrellas he sold and the rainfall in centimetres each month last year. In January this year, the rainfall was 6.1 centimetres. During January, he sold 32 umbrellas. Show the information on a scatter graph. So what I've really got to do is go to 6.1, go to 32 and put a cross. So if this is 6 and there are 10 squares in between here and 7, then 6.1 is right there. Okay, that's 6.1, and so I'm going up 6.1 and I want to go up to 32. So again, there's 10 squares in between each of these, so 6.1, this is 30, 31, 32, right there. Done. What type of correlation does this show? So there are 3 answers to this question. What type of correlation? You can either write positive, or you can write negative, or you can write no correlation. Those are the 3 acceptable answers. Now in this case, it is clear to me that there is a positive correlation. What does that actually mean? So the answer is positive, by the way, positive correlation. Now what that means, if I was asked to describe the relationship, what that means is the greater the rainfall or the heavier the rain, the more umbrellas that you sell, that Mr. Wither sells. So, and it makes complete sense when you think about it. You know, if it rains more, then you are likely to sell umbrellas. If it rains less, you're less likely to sell umbrellas. So the data generally follows that sort of trend. As you increase the x-axis, you increase the value on the y-axis. In excuse me. In February this year, Mr. Wither sold 40 umbrellas. Estimate the rainfall for February. Simplest way to do this is to use a line of best fit. So we're going to draw a line that goes through the data as accurately as you can. So that sort of goes through as much of the data as I can make it. So there's my line, and it says he sold 40 umbrellas. So you're going to go to 40 and you're going to read across. And wherever that touches your line of best fit, that is your estimate for the rainfall. Okay, so 40 touches the line just here. So I estimate 7.1 centimeters of rainfall. 7.1, because that's where my line of best fit tells me. If he sells 40, I estimate 7.1 according to the data. Question 8. Question says, reflect triangle P in the y-axis. Okay, the y-axis is this axis here. So what I'm basically doing is imagining if I was holding a mirror here, where would this shape end up? If I held a mirror here, what would I see? Alternatively, and this is the way I've always preferred to do this question, because we don't give you mirrors anymore. In primary school, you know, you used to get a mirror. These days, you just need to think. Well, what's the distance between here and the reflection point? So from here to the reflection line is 2 squares to the right. So you're going to take 2 squares out. Okay, think of it as in and out rather than right and left. So here I go 2 squares in, 2 squares back out again. So that point ends up here. This point is going to be reflected here. This one I go 1, 2, 3, 4 squares in. So I'm going to count 1, 2, 3, 4 squares out, and that is the reflection of my triangle in the line, or in the y-axis, I should say. If you want to label it, you can label it. I don't know, Q. Oh, actually, there's already a Q down there, so I might just, well, don't label it then. It doesn't tell you to, but if it does tell you to label it, then label it. So there's my reflection. Okay, I'll just shade it in. It might be a bit easier to see with the lines. Okay. Next question. Draw an enlargement of shape Q, scale factor 3. Scale factor 3 basically means draw Q 3 times bigger. So we're going to do that now. It really is up to you where you draw it, any way you like. I'm just going to check. So it's 1, 2, 3, 4 across. So I need to have space for 12 because 4 times 3, that 4. This is 4. This is 2. This is 3 here. Yeah? I'm just counting the squares. That's going to become 12. That's going to become 6. That's going to become 9. So I just need to check I can fit 12 across. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I can fit it from here across. And again, I can fit 6 up. 1, 2, 3, 4, 5. Yep. Okay, so I've got space here. I'm going to put it just here. So again, I'm going to double check my counting. So I need to count 12 squares across. So if I start it there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, just to there. And then the 2 is going to become 6. The 2. So the 2 becomes 6. So I'm going to count 6 squares up. 2, 4, 6. Again, the 3 is going to become 9. So I'm going to count. Excuse me. I'm going to count 3 squares across. Sorry, 9 squares across, not 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the last bit, I mean, you can count it. It was down 2 and across 1, so that's going to become down 6 and across 3. Or you can just connect it. You really don't have to worry too much about counting it. But it is down 6, 1, 2, 3, 4, 5, 6, and across 3, 1, 2, 3. Alright, and there's my new shape. That is enlarged. Okay. Again, apologies if you can't really see that. I'll try and shade it in a bit, make it easier to see. There it is. Question 9. A pile of sand has a weight of 65 kilograms. Some of the sand is put in a small sack, the rest of the sand is put in a large sack. The sand in the large sack weighs 15 kg more than the sand in the small sack. What is the weight of the sand in the small sack? I would strongly advise you to form an equation here. So, you know that altogether, small plus large is 65, yeah? If I just put S plus L equals 65, you know that. You also know that the sand in the large sack is 15 more than the small. So the large is small plus 15. Okay? So if I just rewrite this now as an equation, I've got small plus 15, and that equals 65. Collect the terms together. I've got 2 small plus 15 equals 65. Take away 15, take away 15. 2 small equals 50. Divide by 2, divide by 2. The small sack was 25. What was the weight in the small sack? 25 kg. You can check it now by putting the number back in. So if I were to say the small one's 25, because small plus large is meant to be 65, yeah? So if that was 25, the large one would be 15 more than 25, which is 40. What is 25 plus 40? 65. So I'm sure I've done this right. Okay, I've checked my work. Question 10. Laura is asked to solve this equation. 6x plus 4 equals 10. Here's her working out. For some reason, don't ask me, for some reason she's written 6x plus 3 equals 9. Now, some of you are going to look at that and say, oh, she's gone wrong straight away. Well, actually, she hasn't. As long as she's done the same thing to both sides, she's okay. And all she's done here, to get from here to here, is she's taken away 1. And to get from here to here, she's also taken away 1. So she hasn't done anything wrong yet. It's just a bit weird. I wouldn't say wrong, just unusual. But the next stage, from here to here, is where she went wrong. The mistake she's made is she took away 3 from this side to get rid of that. But on this side, she added 3. Now, if you take away 3 on the left, you're supposed to take away 3 on the right as well. So her mistake is she subtracted 3 from the left side, but added 3 on the right side of the equal sign. So that's her mistake. So her mistake was between, if I call this line number 1 and line number 2, that was her mistake. It was between line 1 and line 2. Because if you notice here, she's taken away 3 there. She was supposed to take away 3 here, but she accidentally added 3 for some reason. So that is the bit she did wrong. Question 11. In August 2008, Eddie hired a car. The cost of the hiring was £620. The exchange rate was £1 equals €1.25. Work out the cost of hiring the car in euros. I'd say this is the first question I've actually needed the calculator for. So really, how do I turn pounds into euros? The answer is you times by 1.25. So 620 times 1.25. 620 times 1.25. 775 euros. Sorry. My handwriting's really bad, but 775. Next, Eddie bought some perfume in Italy. The cost of the perfume was $50. The cost of the same perfume was £42. The exchange rate was the same as it was in part A. Work out the difference in the cost in Italy and London. Give your answer in pounds. So step 1, we need to convert to pounds, and then step 2, we need to work out the difference. So let's convert to pounds. Now, sorry, I can't spell either. Difference. So look at the exchange rate. How do I turn euros into pounds? Okay, how do I turn them into pounds? You divide it by itself. If you divide something by itself, it makes it 1. So €1.25 divided by 1.25 gives you 1. So $50 is how much it cost in Italy. 50 divided by 1.25 gives us £40. So I'm comparing Italy cost, which was £40, with London cost, which was £42, and the difference between those therefore is £2. Difference equals £2. Done. Question 12. An internet bookshop uses this advert. Each day, every 3rd customer gets a mystery prize. Each day, every 20th customer gets free postage and packaging. Okay? On Tuesday, the internet bookshop had 150 customers. How many got a mystery prize? Well, if every 3rd customer got a mystery prize, so just for a moment, humor me and let's write a list of customers. So customer 1 doesn't get anything. Customer 2 doesn't get anything. Customer 3, congratulations, mystery prize. Customer 4, no, nothing for you. Customer 5, nothing for you. Customer 6, congratulations, mystery prize. Customer 7, nothing. Customer 8, nothing. Customer 9, I hope you're starting to see the pattern. Every 3rd customer, yeah, 3, 6, 9, 12. So really what you're basically saying is, how many 3s do I fit in 150? The answer, 150 divided by 3 is 50. So there are 50 people going to get the mystery prize. My guess is the mystery prize is something really rubbish, like, well, actually, I don't want to. Doesn't matter. I don't want to add judgment here, but yeah, something cheap, like, I don't know, a free pen. Congratulations. Part B. How many of the 150 customers got free postage and packaging? Now that is probably worth a bit more money, so that's why they've made it a bit more rare. 20th customer. So the 20th customer gets it. The 40th customer gets it. The 60th, 80th, 100th, 120th, 140th, and then after that will be the 160th, but they didn't get 160, so I'm going to put that in brackets. So how many? 1, 2, 3, 4, 5, 6, 7. 7 customers. Next part. How many of the 150 customers got both mystery prize and free postage? Okay. So really, my question is, how many in the 20 times table and the 3 times table? I hope that makes some sense to you. So how many of these numbers basically come in the 3 times table? So what I'll do is I'll actually write them again. 20, 40, 60, 80, 100, 120, 140. So these are all of the free postage and package winners. Now I'm going to circle all the numbers that come in the 3 times table. Nope, nope, yep, nope, nope, yep. So how many customers got both? 2. Alright, the 60th customer and the 120th customer, lucky them, got free postage and package and a free mystery prize. Question 13. Mrs. Phillips needs to decide when to have the school sports day. Oh, the joy! Sports days, yay. The table shows the number of students who will be at the sports day on each of 4 days. It also shows the number of teachers who can help on each of the 4 days. For every 12 students, there must be at least one teacher to help. On which days will there be enough teachers to help out at the sports day? Excuse me. Honestly, I think the easiest way to do this question, guys, is to multiply this number by 12. So each of those numbers, times them by 12. Use a calculator to do it. So 15 times 12, that's 180. 13 times 12, that's 156. 14 times 12, that's 168. 12 times 12, that's 144. So what I've just worked out is, because for it to be safe, there has to be, for every 12 students, has to be one teacher. So with 15 teachers, we can have 180 students. So as long as this number here is less than 180, then it's all good. So I'm going to put a tick there. That day is all good. On this day, I can only have 156 students, so too many. Not a good day to have the sports day because it's not going to be safe. The ratio is not right. This day, I can only have 168 students. There's going to be 170. Not a good day. This day, I can have 144 students, 143. That's another good day. So which days will there be enough teachers at the sports day? Tuesday and Friday are the two potential days. Next. Question 14. 30% of something is 120. Work out the number. Well, if 30% is equal to 120, how can I turn the 30 back into 120? There are a few different ways, guys. You can divide by 30 to get 1%. Divide by 30 to get, what's 120 divided by 30? 4. And then times by 100, times by 100, and that will give me 100%. So what the full number is 400. That's one way. Alternatively, if you know what you're doing with your decimals and your fractions, you know that 30% is equal to 0.30. So you could just do 120 divided by 0.3. There we go, 120 divided by 0.3 in one step, 400. So that or that, either of those I'm happy with. 3 marks. Next question. Show that 7.5 take away 4 2/3 equals 2 5/6. So this is subtracting fractions. First step, top heavy. Second step, cross and smile. Third step, and I'll put this one in brackets because you don't always have to do this, simplify, because sometimes you can't simplify. Okay? Alright then, so step 1, make it top heavy. 7 times 2 is 14, 14 plus 1 is 15, 15 over 2. Next one, 4 times 3 is 12, 12 add 2 is 14, 14 over 3. So I've just made that and that top heavy. Now, cross and smile. 15 times 3 is 45, 14 times 2 is 28. There's a subtraction, so I'll put a subtraction. 2 times 3 is 6. Next, 45 take away 28. Don't take any risks. 17. 17 over 6. Now 17 over 6, well, if you put it in the calculator, it's just going to say 17 over 6. Now, how do I turn that back into a mixed number? What you've got to say is, how many 6's go into 17? So I'm counting up my 6 times table. 6, 12, 18. So I can't fit 3 in, because 18 is too much. So 2 gets me to 12. 2 whole ones. And what's the remainder? To get to 17 from 12? 5 6. So I've just shown that that ends up being 2 5/6, which is what they want me to show, 2 5/6. So this is a constructions question. I can already see it, so I'll probably need this, and I'll probably need this, and I'll probably need this. Let's read the question. Question says, the diagram shows the map of a field. On the scale, on the map, the scale is 1 centimeter to 20 meters. A and B are 2 wind turbines in the field. A third wind turbine is going to be put in the field. There must be at least 100 meters between turbines. Show by shading where the third turbine can be put. Right. Basically, if I've got to leave 100 meters between turbines, then what I've got to do is, on the map, I need to draw arcs or lines to represent where that 100 meters is. Now, if it tells you 1 centimeter is 20 meters, what would 100 meters be represented by? Well, 100 divided by 20 is 5, so 5 centimeters. Okay, so what I'm then going to do is I'm going to take my compass. The way a compass works, by the way, is you line up the pencil and the point, and then you need to use a ruler to measure this open to 5 centimeters. So 5 centimeters is right there. There it is. Hope you can see that. Sorry, let me move my hand out of the way. 5 centimeters is there. And then what I'm going to do is I'm going to draw an arc or a circle centered on B. There's one. I'll just draw it all the way around to here. So the wind turbine can't be inside this circle, because anything inside this circle is nearer than 100 meters. This circle basically represents 100 meters away from B. If I put the turbine here, then that's okay. If I put it anywhere around here is good, but inside here is no good, because it's got to be more than 100 meters away from it. Now we've got to do the same thing with A, so I'm going to draw another circle around A. There's my second circle. Now I can shade, does it say shade? Yeah. Show by shading where the turbine could be. So the turbine has to be outside of these circles. So if I just shade the region outside the circles, so it can be anywhere over here, anywhere over here, this is all good. Any of that region is good. Okay, I can't put it inside these circles because that will be too near to B or A or both. If it's inside this bit, it's too near both. Okay, that's question 16. Question 17. The diagram shows the lines of a netball court. Excuse me, I'm stretching. The court is made from 3 rectangles, 1, 2, 3, and 2 semicircles, 1, 2. All the corners are right angles. Mr. Handy, that's a good name for a carpenter, handyman, is painting the lines for the netball court on the floor. Work out the total length of the lines of the netball court. Court on the floor of the school sports hall. 3 rectangles and 2 semicircles. So yeah, I mean, I think pretty straightforward. If I grab a highlighter, what I'm doing really is I want to work out the length, the total length. Okay, this highlighter is like dying, but it still serves the purpose of all of these lines. Those. I'm gonna swap to another highlighter. Hopefully this one works. Plus this one. That's a different color, but whatever. Plus this one, because this handyman fella is going to be painting these lines. Okay, so he wants to know how much paint he needs. So that's all the way around the outside, plus that, plus that, plus this, plus this. Alright, let's deal with the straight lines first, because they're easy. So I've got 30.5 here, I've got another 30.5 opposite. Okay, if I've got 15.25 here, I've got another 15.25 there, another 15.25 there, and another 15.25 there. So hopefully you can see so far I've got the long lines on the edges, the 1, 2, 3, 4 lines crossing through. The last bit then is these semicircles. Now what that really is the circumference of the circle. And I've got a half circle here and a half circle here, and they're identical. The radius is the same. This is the radius, by the way. And they're the same. So if I just add up the 2 halves, I've got a full circle. So how do you work out the circumference of a circle? Cherry pies delicious. By the way, apple pies are 2, but you don't need that formula today. So cherry pies delicious. Here is what you're going to do. Circumference equals pi times diameter. Diameter means, if I drew a circle, this is the diameter and this is the radius. The radius is halfway, the diameter is all the way. Okay, so if I know that the radius is 4.9, then the diameter, if you imagine I just draw the other half of this circle, it's a really bad drawing, but there it is, would be another 4.9 that way. So altogether 9.8. So pi times 9.8. There we go. Pi times 9.8 is 30.78760801. And finally, I'm going to add, obviously I did say already, that's half of that, but that's also another half of that. So altogether, you can just leave it as it is. If you prefer, you could divide it by 2, which will give you 15.393804, but then just remember you've still got 2 of those. You've got one on this side and you've got one on that side. So it's up to you. I'm not going to divide it by 2. I'm going to leave it as 30 and use that. But anyway, let's now add this all together. So I've got 30.5 plus 30.5 plus 15.25 plus 15.25 plus 15.25 plus 15.25. That's all of those, plus the semicircles, which, as I say, I'm just going to use that one number, 30.78760801. Final answer for me then, 152.787608. Okay, what I've done there is I've just added together, I will write it because I know I've just put it on the calculator, but in case you've lost me along the way, 30.5 plus 30.5 plus 1, 2, 3, 4 lots of 15.25 plus 30.7876 blah blah blah, and that gives me a total of this. It's said to the nearest meter, so 7 is going to round this up to 153 meters. So there's your answer, 153. Okay, on the grid, draw the graph of y equals 3x minus 2 from minus 1 to 3. So step 1, table of values. Step 2, plot and join. I can't spell. And join. So, table of values, here we go. Nice, simple table of values. It told you to go from minus 1 to 3, so x and y, minus 1, 0, 1, 2, 3. Here we go then. If I substitute minus 1 into here, this is for minus 1 then, I'm doing 3 times minus 1, take away 2. 3 times minus 1 is minus 3, take away 2 is minus 5, so that's minus 5. Now I'm going to do 0, and I'll do that one down here. 3 times 0, which is 0, take away 2, which is minus 2. Next one, I'm going to put it over here. 3 times 1, which is 3, take away 2, which is 1. Now, hopefully at this stage you'll have noticed the pattern. It's going up in 3s every time, yeah? It goes up by that number. So, add another 3, add another 3. I've now got my table of values. Step 2, plot the points and join them together. So, minus 1 and minus 5 there, 0 and minus 2 here, 1 and 1 here, 2 and 4 here, 3 and 7 there. Final step then, join these together and there's your answer. So I've now drawn the line connecting those 5 points. Question 19. Abby is 5 years older than Kathy. Bhavna is twice as old as Abby. The total of their ages is less than 30. What is Bhavna's greatest possible age? Give your answer as a whole number. You must show all you're working out. Okay, so I'm going to start with Kathy as a starting point. So Kathy is C, Abby is A, and Bhavna is B. Now, if Abby is 5 years older than Kathy, then I can say that A is C plus 5. Okay? Kathy plus 5. And Bhavna is twice as old as that. So Bhavna is 2 lots of C plus 5. Hope you can all see that. Okay? And obviously Kathy, she's just Kathy. Kathy is Kathy. So what I'm now going to do is I'm going to form myself an inequality, because it says that the total of their ages when I add them together is less than 30. So A plus B plus C, A plus B plus C is less than 30. But I'm going to replace A and B with these two expressions. So C plus 5 plus 2 lots of C plus 5. Remember, Abby was twice as old. Bhavna was twice as old as Abby. Plus Kathy's just on her own, is less than 30. Now let's expand this bracket here and collect some terms together. We'll do that in a second. 2C plus 10 plus C less than 30. So collect the C's together. I've got 4 C's, and collect the numbers together. I've got 15, and that is less than 30. So 4C plus 15 is less than 30. Now let's work out what the oldest that Bhavna could possibly be. So let's work out C. So take away 15 both sides. That gives me 4C is less than 15. Divide by 4 both sides. C is less than 15 divided by 4. Well, half of 15 is 7.5. Actually, sorry, it's a calculator paper, so just do 15 divided by 4. 3.75. So C is less than 3.75. Okay, now with that answer in your mind, or with that number 3.75, we're going to put that in here. Okay, so Bhavna, the oldest that she could possibly be is 2 lots of 3.75 plus 5. So 2 times 3.75 plus 5. That's the oldest. This is Bhavna, by the way. Okay, so 2 times 3.75 plus 5. And that gives me an answer of 17.5. So the oldest that she could be is 17.5, but it wants me to give my answer as a whole number of years. Now, I can't, even though you and I both know that we'd round that up to 18, I can't do that in this case, because if I made that 18, then our total would end up being more than 30. If I say Bhavna is 18, then that would mean Abby is 9 and Kathy is 4. And 18, add 9, add 4 is 31. So it would be too much. So you can't round it up. What you actually have to do in this case, because it's an inequality and it asks for a whole number, you're actually going to round this down and say the oldest that she could be is 17. You can test that if you want to, so let's test it. If Bhavna is 17, that would make Abby half of 17, which is 8.5, and that would make Kathy 5 years less than that, which is 3.5. And if I add these three together here, 8.5 plus 17 plus 3.5, my answer is 29, which is less than 30. Question 20. The table gives some information about the birds Paula sees in her garden one day. Complete the accurate pie chart. Okay, so, excuse me, we have done pie charts. My set 3s both have done them, and therefore I would hope the set 4s and 5s have also covered this by now. First thing is I'm going to total these together, so let's work out the total. 15 add 10 add 20 add 27 is 72, and you should all know that the angles in a pie chart are always going to add up to 360. So how do I turn 72 into 360? Or alternatively, depending how your teacher has taught you this, you may have been taught to say, for example, 15 out of 72 times 360, and 10 out of 72 times 360, and so on and so forth. So 15 out of 72 times 360 gives me 75. This is, sorry, the angle size. Next one, 10 out of 72 times 360 is 50. Next one, 20 out of 72 times 360 is 100. Next one, 27 out of 72 times 360 is 135. You can check you've done that right by adding these together. 75 plus 50 plus 100 plus 135 is 360, so we're all good. Now we need to actually draw these angles. So they've already done Magpie for us, so let's just check. I mean, not that we should have any doubts, but we'll check the exam paper's done it right. Should be 75. Yep, bang on 75. So next one's going to be 50. This is for thrush. So I am going to put the pie chart, sorry, put the protractor right in the middle. Sorry if you can't see that, let me just push this up. And I'm measuring from 0 round to 50 for the how many thrush birds that this lady Paula saw. So there's my 50 degrees, and that is for thrush. Next is 100 degrees. So you measure round, put the protractor round till it gets to the 0 again, and you're measuring round to 100. So 90 is here, 100 is there. Put a little dot, connect it together. That one is starlings. So starling. The last bird is a sparrow, and I don't need to measure it. You can do it just to check. So this should be 135 degrees if I've done this right, and I hope you can all see, excuse me, that is bang on 135 right there. Okay, so that one's 135, which is sparrow. Right, there are only red and blue pens in a box. There are 12 red pens in the box. The probability of taking a random blue pen from the box is 2/3. Work out the total number of pens in the box. Well, if the probability of taking a blue pen is 2/3, what must the probability of taking a red pen be? Okay, remember it's got to add up in total to a full whole one. So the probability of blue is 2/3. That means the probability of red must be 1/3, because 2/3 add 1/3 makes 3/3, which is one, a whole one. Now there are 12 red pens, and I know that that represents a third. So 12 pens represents 1/3 of total. How do I get the total then? What do I need to do to both sides? I'm going to multiply by 3, which gives me 36 pens. Okay, so 36 pens is the total. Question 22. Henry is thinking about having a water meter. These are the two ways he can pay for the water. He uses an average of 180 litres each day, and he wants to pay as little as possible, so we want to find the cheapest option. These are the charges with the water meter. You get a fixed charge plus a usage based rate, and with no water meter it's just a fixed charge. So let's work out then the total if I had a water meter. 180 litres of water per day, and okay, so we need to basically times that by 365, because that'll tell us how much he uses in a year. 180 times 365 is 6,700. That's per year. Okay. Next, if he uses 65,700 litres per year, how do I turn that into cubic meters? Well, divide by 1,000, and that is 65.7 cubic meters. Okay, now you have to charge 91.22 pence per cubic meter. So for each one of these, he gets charged 91.22 pence. So let's work that out. 65.7 times 91.22. Oh, apologies. 65.7 times 91.22. That gives me 5993.154, and that's pence, remember. So let's now turn it into pounds. Divide that by 100. 59 pounds and 93.154 pence. 2 decimal places because it's money, so that's 59 pounds 93 pence. That's the water based charge. Don't forget to add on the £28.20 fixed charge. So £59.93 plus £28.20 gives me a total water bill of £88.13. So what I'm basically doing is comparing that versus £107. Okay? And what you've got to answer is, oh, remember, he wants to pay as little as possible. So which one of these two options is cheaper? Water meter or no water meter? Answer, obviously, is water meter is cheaper. Okay. Question 23. Here are the first 4 terms of an arithmetic sequence. Find the nth term. This method is tried and tested. It works every time. It's called the Dunno method. I don't know how to do it. D stands for difference. N, you just write N. And 0 means you go back one to find the 0 term. So this is the first term, second term, third term. This would be the 0 term. Now, the pattern goes up by 7, yeah? So if I go back, I take away 7. Alright, so 3 take away 7 is minus 4. And I've just told you it goes up by 7 each time, yeah? So the difference each time is 7. The 0 term is minus 4. The answer then, 7n minus 4. Is 150 a term of this sequence? Well, easiest way to work this out is to make an equation. 7n minus 4, does it ever equal 150? With n being a whole number. So let's add 4 to both sides. Add 4, add 4. 7n equals 154. Divide by 7, divide by 7. Calculators are your friend. 154 divided by 7 is 22. So the answer is yes, it is the 22nd term in the sequence. Now, that is one way you could have done it. The other way, obviously, some of you will have done is carried on. Just keep adding 7. So, I don't know, 31, 38, 45, blah, blah, blah. That will take you a long time to get to 150. You will get there if you've done it right, but it'll take you a long time. So, my advice is to get used to using this method. What you're basically looking for is an integer here. Integer. If your answer was a decimal, then you'd say no, it isn't in the sequence. But because my answer was a whole number, 22, I know it's the 22nd number. Effectively, when I put 22 in here, so 7 times 22, and then I take away 4, there you go, gives you 150, right? So when 22 is in there, you get that answer. Question 24. Each year, Wenford Hospital records how long patients wait to be treated in A&E. In 2015, patients rated 11% less than in 2014. In 2015, the average time was 68. Work out the average in 2014. Well, they've just told you 2015 was 68 minutes. And they've also told you that this was 11% less than 2014. So, if 2014 was 100%, what's 11% less than that? That's right, 89%. So 68 minutes is 89% of 2014's total. How can I turn this back into 100%? Some of you, if you know your decimals and your percentages, will say, oh, just divide it by 0.89. Yes, that works. You could do that. Alternatively, if you're not so happy with your decimals, you could divide it by, so that's method 1, okay? I'll just put that in a box. And that will give you 68 divided by 0.89. That will give you 76.404 blah blah, which is 76 minutes. Alternatively, if you know that 68 is 89%, divide by 89. That will give you 1%, which is 68 divided by 89 is that 0.764 la la la. Then times it by 100 to give you 100%. That works too, and you get the same answer, 76.404 la la la. Okay, so you could do it that way. That's sort of method number 2 if you like, or you could do it this way. If you're happy, you understand that 89% is the same as 0.89. So to get that into 100%, you divide by 0.89. Next. The hospital has a target to reduce average time patients wait to be treated to 60 minutes. Work out the percentage decrease, percentage change, from 68 to 60. Well, percentage change is change divided by original times 100. So, work out percentage decrease here is, what's the change from 68 to 60? 8 divided by the original, 68 times 100. That's all you got to do. So, with your calculator, 8 divided by 68 times 100 gives me a total of 11.764705 blah blah blah. Doesn't tell you what to round it to, so I'm going to round to one decimal place, or 3 significant figures in this case, 11.8%. That is the percentage change from 68 to 60. Okay, last couple of questions here. Each length of the side of square B is twice the length of the side of square A. John says this means the area is also twice. Is he right? Justify your answer. Easiest way, I would say, is to... So, as I say, the best way to do this is to use numbers. So I would have my drawing of square A, and let's say it was 5 centimeters, 5 centimeters, 5 centimeters, 5 centimeters. The area would be 5 times 5, which is 25. Now I'll draw square B, which is 2 times bigger. So instead of 5, it's 10 centimeters, 10 centimeters, 10 centimeters, 10 centimeters, 10 times 10, 100. So the area B is 100. Is that twice as big as that, or is it 4 times as big as that? That's right, 4 times. So, is John right? No. The area is 2 squared times bigger. What's 2 squared? 4. Okay, so it's 4 times bigger. Final question. Solve x squared plus 3x minus 10 equals 0. Right, solving quadratics. There's a few different methods at this stage. And given that this is a foundation paper, my go-to method will be factorizing. So factorizing means find a pair of numbers that times to make minus 10 and that add to make positive 3. Okay? You know it's going to be x and x because that's the only way to make x squared. So what 2 numbers times to make minus 10? You've got 1 and 10. As in, could be a minus and a plus, but we'll deal with the signs in a minute, or 2 and 5. Now, can I make 3 out of 1 and 10? 10 take away 1? No. 1 take away 10? No. 10 add 1? No. 5 take away 2? Hello. Okay, 5 take away 2 is 3. So, positive 5, negative 2. 5 and minus 2. Now, if that is equal to 0, your solutions are that and that, but flip the signs. Okay? So, instead of writing 5 and minus 2 on the answer line, my answer line is going to be x equals minus 5 or positive 2. There's the answers. Okay, so 2 answers. 5 or minus 5 or 2. So remember, it's the numbers that you end up with in the bracket, but you have to flip the signs. I hope you've found this video helpful.